Kyle Mystical here, and along with me today is Dr. Casey Theriot. And I gotta ask, what's the story behind the art on the wall?
Oh yeah, so the artist is actually my sister, Renee Theriot Fox. And so she's a very talented artist, and so I gave her two pictures. One is confocal microscopy on the right here of the section of the mouse gut, and then on the left, and many people know this, but a lot of people don't know it, and then on the left is just a transmission electron microscopy of Clostridium difficile.
So what have you been up to these days? You have a new grant, I hear?
Yeah, so I've been at the vet school for about 2 years now, almost completion of 2 years, and we've been very excited in the Theriot lab to get a major R grant from the NIH when I first started here. And so what we're doing on that particular grant, what the lab is working on, is looking at how the gut microbiota in the mouse and also in humans provides something called colonization resistance against Clostridium difficile, which is a significant nosocomial pathogen right now in the US and around the United States. So C. difficile is a spore-forming organism. It thrives in this environment, and we know a couple of things about that environment. We know that after antibiotics, you basically get rid of a lot of C. diff's competitors. So a lot of the bacteria that are altered in the gut, they can compete for similar nutrients than C. diff can, so C. difficile thrives. We also know that after antibiotics, you have an alteration of the gut bacteria that can produce secondary bile acids, and secondary bile acids can actually inhibit C. diff. So we think that there are two mechanisms by which the gut bacteria are providing protection against this incoming enteric pathogen. And so what my lab is doing, and what this grant, what we've been funded to do, is to really dissect those particular mechanisms and to really understand bacteria that are able to produce secondary bile acids. Can we add those back into an antibiotic depleted gut? And we have a mouse model that approximates C. difficile infection beautifully in the lab. And then the other part of this is we're looking at adding back specific bacteria, other Clostridia that are commensals, which can actually compete against the same nutrients as C. diff. And we don't think it's one or the other, we think it's actually both of these things that are providing for colonization resistance against C. diff. And the idea of this, doing this work, is that by understanding these basic mechanisms of colonization resistance, we hope to design new targeted bacterial therapeutics to help treat people with C. difficile infection and also prevention of disease as well. And that's pretty much the future, goals, but we've basically been on year 1 of this grant so far.
Very interesting. Well, thanks for sharing.
Well, thank you very much, Kyle.